Alright, these are notes on heat and plate tectonics. So what's inside the Earth? So we're doing Earth systems with how heat is transferred. So as the part of the Earth that we live on is called the crust. So it's a very thin layer right here if you see the picture on the planet. Then inside is the mantle. It's semi-liquid layer. It's very hot. It can get up to 3,700 degrees Celsius. Then inside there's an inner and outer, but we're just going to look at the core as the center. And it gets even hotter as you go inside, and that could go up to, depending on certain spots, up to, or more than actually, than 7,000 degrees Celsius, which is very, very, very hot. So cool crust, very hot mantle, very even hotter core. So here's a picture by temperature. So even we're on the crust there, even going in 1600 Celsius, it's 3,700 Celsius, then going up to 5,000 Celsius and even greater than 5,000 Celsius. Where did all the heat come from? So most of the heat came from the formation of the planet, and when Earth formed, it was a molten ball of rock, and it cooled from the outside in. So just like, think of a hard-boiled egg. On the outside, it's cool, and it cools down pretty quickly on the shell. But when you open it, when you crack it open, the white layer is still pretty warm and it's really hot in the middle, and it takes a longer time for it to the heat to transfer out. So that would be analogous to the Earth. There's a lot of heat here and a cooler outer layer. So what is the Earth? The Earth's basically a big giant rock that is this many kilometers. Let's see, this would be 1,000, 100,000 million, right? Billion, trillion, trillion. I lost count. Well, it's very large. Kilograms. This is not the density, this is just the mass. So it will take a very long time for the center of the Earth to cool down. So if you think of, we're not looking at, this is just the mass, but look here, this would be the actual diameter from the poles here, and it's about 12,700 kilometers. How long would it take to cool down? Scientists believe it's been cooling for many, many billions of years and it's still not cool yet. So if we're talking about heat transfer, so how does heat transfer? So we've learned about a couple, we haven't named them. So here are 3 ways heat energy transfers. And the 3 ways are convection, conduction, and radiation. And basically what we've been learning in class is conduction. So things that have contact with each other, but we'll go more further and we'll define each 3. So convection and conduction are 2 methods of heat transfer that require matter. So it requires some type of a medium to carry it. But radiation requires no matter, no medium to carry that heat. So pretend you had a campfire and you're boiling some water and you had a pan right here, a pot. So as you're burning the fire, whatever the wood or coal, heat's radiating out. So nothing's really touching this pot, it's just the heat radiating out. Radiant heat, think of it that way. Then as the water's boiling, there's convection. The hot water molecules here become less dense and start rising to the top, and the cooler water molecules go down. So there's this convection flow, rising and then dropping down. And then conduction is when, like this person's hand is actually in touch with the metal. So he's conducting from the hot metal to the hand. So if there was no rubber handle, it would burn this person's hand. So once again, these conduction, convection required matter to conduct it through, while radiation doesn't. So let's look closely at radiation first. So radiation is a method of heat transfer that does not rely upon any contact between the heat source and the heated object, just like the fire and the pot it was heating. Heat can be transmitted through empty space by thermal radiation. Thermal meaning heat. So what is radiant energy? So radiation can be energy from visible light. So think of waves. X-rays, UV rays, infrarays, microwaves, and gamma rays. So here's the spectrum. This is called the electromagnetic spectrum. These are the longest waves, like radio waves. And then you have your radio frequencies, microwaves, infrared, and then here's our visible light rays, UV, X-ray, and they get shorter, and these are more energetic, by the way. And these are gamma rays. So this is your visible spectrum. Do you see the colors right here? Okay, where does Earth get new energy? So we were talking about when the Earth was formed, it was hot and it's cooling down. But how does it continually get more new energy? So radioactive elements are buried inside the Earth, like uranium. They release radiation, which are called gamma rays, which warm the interior of the Earth. So basically, a radioactive isotope releases particles. They actually decay or break down, and they release energy. So how does the sun receive radiation? How does the Earth receive? So once again, just to review, the Earth is hot and inside, cooling down. New energy is formed by radioactive decay, but it can also get heat from the outside. So the sun transfers energy in the form of radiation, so in the form of visible light, because we get daylight from that, infrared, and ultraviolet. And that's what gives you, that's why we wear sunblock, because that would burn and cause skin cancer. So we're finished with radiation. Now we're going to conduction. So conduction is what we've been talking with, basically matter in contact. So conduction is a transfer of heat between substances that are in direct contact with each other. So that's why they can reach thermal equilibrium. So the better the conductor, the more rapid heat will be transferred. So if this was metal and we're putting it on top of the candle, there'll be heat, and the heat will travel through, and heat will be transferred to this person's hand, and it might burn them. So now we're going to the third method of heat transfer, which is convection energy. So convection occurs when the warmer areas of a liquid or gas rise. So the warmer areas, which are usually on the bottom, they rise to cooler areas in the liquid or gas. So they're all in one area, either a liquid or a gas. Cooler liquids or gas then take the place of the warmer areas, which have risen higher. The result is a continuous circulation pattern. So look right here. So if you had like one of those floor heating units, it would heat up the air, right? Heat rises. Well, actually hot air is less dense, so it rises up to the top. Then the cool air that was up on the top falls to the bottom. Then it gets warmed. Then it keeps going back and forth until the whole room is completely warmed. And this is called convection. A circular pattern right here. Air cools and sinks, warm air rises to the top. Okay, what type of heat transfer is in the mantle? So the member of the mantle, where is that? The mantle is, the crust is where we are at, and the mantle's the layer within the Earth. Hot material expands and decreases. So how the hot material here expands, decreasing their density and causing them to, the hot material down here near the core, the mantle that's near to the core, it's hot. It expands, it's less dense, and then it rises to the top. It's rising right here. Then cooler material that's up top in the upper mantle, nearer through the crust, descend down, they fall down to fill the space that's just left. So they're making convection currents like this. How does convection appear on the Earth's surface? So convection also happens inside the Earth's surface. Below the Earth's surface, and it actually causes plates to move, and we'll talk about plates next. So this is the source of movement of plates, because the heat energy and the heat transfer of the convection in the mantle. There is also convection above the Earth. So The sun rays, obviously we talked about the UV, the visible, and the infrared. The heat in the form of light toward the planet and heats the surface, which conducts the heated air. This heats the surface, which conducts heat to the air touching it. Right, you're heating the air. Hot air expands and rises, so we're going to the air up. Cooler air fills a void that the hot air filled, that left. Cool air descends down and begins to circulate, and the circulation is called convection, and it starts with the light energy from the sun. Okay, and then now we're going to talk about plate tectonics. So the plate tectonics is actually a theory that on the top of the Earth's mantle are several plates of rocks that the crust sits on. So the crust is what we're exactly standing on, and the plates are like the upper part of the mantle, and they're plates. So as you can see, these are the boundaries of these plates. Right here, there's Pacific plate, North American plate, Caribbean plate, and then when they're talking about earthquakes and things like that, see how we live near, it's called the San Andreas Fault over here in Southern California. We're on the edge of two plates. So how do plates move? Plates sit on the mantle and move around slightly due to the convection currents from the Earth's interior. So once again, the convection currents are moving, and you have plates that are movable. They can move depending on the convection currents. Since the convection currents are moving this way, this plate's moving that way. The convection currents are moving to the right, so this plate's moving this way. If convection currents are moving to the left, this way. So the convection currents actually influence the way the plates are moving. So what are the types of plate boundaries? So between plates. So there are divergent, so they're moving away, convergent, moving toward, and transform. They're kind of moving not toward or against, but kind of sideways. Away from each other, I guess. So what are convergent plate boundaries? Convergent plate boundaries is where two or more tectonic plates of the lithosphere, that's the part of the mantle that the plates are on, move toward one another and collide. It forms trenches. So here's a continental plate and an oceanic plate, and it goes down, forms trenches, and can form volcanoes here. And volcanoes is where a lava comes out, or the magma that's coming out. What are divergent plate boundaries? Divergent plate boundaries is where two tectonic plates, they're moving away from each other, and it forms rifts. So it's breaking apart right here. So this is a mid-ocean rift. This is the Rift Valley. That's the lithosphere, right? And that's the crust. And yeah, these are the different spheres of the mantle. And lastly, this is the transformative plate boundaries. Transform boundaries are places where plates slide sideways past each other, and these are usually the location of earthquakes. So one continental crust is moving upward, while this plate, maybe an oceanic plate, is moving downwards, and there is friction in between. Alright, this is a practice, and you can write it down. I think I need to add another one right here, so we'll do that in class.